Okay, so let's get started. This is some questions that were asked in Algebra Talk. And let me see if I can get this zoomed in a little bit better before we start. Okay, so I hope that's good. In any case, so we're going to be working with powers and roots. And the first one we're going to do is we want to find the cube root of 24. And what that's asking, we want a number that if you multiply it by itself 3 times, you get 24. Okay? Um, so one way to do that is I'm just going to take 24, and I'm going to notice that 24 is equal to 6 times 4, and we know that 6 is equal to 3 times 2, and 4 is equal to 2 times 2, right? So we know that 24 is equal to 3 times 2 times 2 times 2, right? Because 3 times 2 is 6. 6 times 2 is 12, and 12 times 2 is 24, which is the same thing as 3 times 2 raised to the third power. Okay? So what we want to do now, and this little tree over here was just to help me break it down into as small powers as possible, because that usually helps me find a cube root. So when we want to take the cube root of 24, I'm going to use a multiplication property. So this is going to be equal to the cube root of 3 times 2 cubed. Okay? Now, whenever I'm doing roots, I can, via multiplication or division, I can break it apart. So I can take it as the cube root of 3 times the cube root of 2 cubed. You can always do that for multiplication and division. That's a 2 cubed corresponding to that 2 cubed. And that's a 3, okay? So the cube root of 2 cubed is going to be 2, okay? So whenever you have a 3 here and a 3 here, they're going to cancel each other out whenever you have the same number here and here. So this is going to be equal to the cube root of 3 times 2, which is generally written as 2 times the cube root of 3. Okay, so we're just simplifying them. So 24, there's no integer that if you multiply it by itself 3 times, you get 24, right? So what we do is we try to simplify it by writing 24 using its prime factorization, and then we just basically breaking 24 down to small terms as possible. 24 is 6 and 4, 6 is 3 and 2, 4 is 2 and 2. So we can write 24 as 3 times 2 times 2 times 2, or 3 times 2 cubed. Now this 2 cubed is a perfect cube, so we're going to use that fact in order to simplify the problem. So taking the cube root of 24 is the same as taking the cube root of 3 times 2 cubed. Now we want to get this 2 cubed by itself, and this is a very important property. We're going to use it pretty much in all the problems that we do up here. That whenever you have the cube root of two numbers joined by multiplication, you can take the cube roots separately and multiply them. Okay? Now this is good because whenever I have the same number here and here, the roots are going to cancel. Which again is nice. Okay? But just remember though, when you cancel these, if this is an even number, your result always has to be positive. And I'll do an example of that in a second. So this is going to be, this and this are going to cancel, give me a 2. And this just says the cube root of 3 because I don't know what the cube root of 3 is, and I can't simplify this anymore. So I'm just going to write this as 2 cube root of 3. Okay? Now, the next one, we're just going the opposite direction. We're starting with two numbers that, roots that are separated by multiplication. We're going to join them together is essentially what we're going to do. Alright? Okay, so let me go into another sheet of paper for this problem. And for this one, we have the fourth root of 8 times the fourth root of 4. So again, what I'm going to do is I'm going to write these numbers as powers of, I'm going to break them down in as much as possible and write them in terms of powers in this case too. So I'm going to notice that 8 is 4 times 2. And I notice that 4 is 2 times 2. And I just bring down the 2. So this is, so 8 is equal to 2 times 2, which is equal to 2 cubed. And 4 is going to be 2 times 2. So 4 is going to be equal to 2 times 2, which is equal to 2 squared. Oops, 2 squared. Okay? Alright. So now what I'm going to do is I can rewrite this problem as the fourth root of 2 cubed, because 2 cubed is an 8. So the gist of this problem is just breaking them down with these in this fashion as I did here as much as possible. So we're going to have the fourth root of 2 cubed times the fourth root of 2 squared. Okay? Now I can't do anything right now because, well, I have a 3 here and a 4 here and a 4 here and a 2 here. Right? To get rid of these roots, I would need a 4 on the inside. Well, I'm going to use the property that, as I did in the last one, here I used it to separate everything. If I just pull the sheet back, here I had the cube root of two numbers, and since it's multiplication, I could separate the numbers and take the cube root separately. Here I'm going to go the opposite direction, right? So I have the fourth roots of two different numbers. So what I'm going to do is I'm just going to combine them into 1/4 root. And I'm going to multiply 2 cubed times 2 squared. Okay? Now, whenever the bases are the same, in this case they're both 2, I can add the exponents. 2 plus 3 plus 2 is 5. So this is equal to the fourth root of 2 to the 5th. Okay, that still doesn't help me because there's a 4 here and a 5 here. I need a 4 in here somehow. So what I'm going to do is I'm going to rewrite this as the fourth root of 2 to the 4th times 2 to the 1, or just 2, because 2 to the 4, and if I put a 1 here I don't have to, the bases are the same. 4 plus 1 is 5, so it's the same as this. Now what I can do is I can separate them again. And I can write this as the fourth root of 2 to the 4th times the fourth root of 2 to the 1, which is really just 2. Now, these two numbers are both the same, so they cancel out. And of course, when I cancel these, if this happened to be a negative 2 raised to the 4th, I would always make it positive, because whenever I take a square root, the output always has to be positive. Okay? So in this case, the 4's cancel, and I wind up with the 2 times the 4th root of 2. And that's my answer there. So again, what we did is, it's the opposite of the last problem. The last problem, we started with this number, and we broke it apart via multiplication into 3 times 2 cubed, then use the multiplication property of roots to just take the cube root of those two numbers separately, separated by multiplication. And since these two numbers are the same, they cancel out, and we wind up with a 2 times the cube root of 3, and we usually write it this way. Here we did the exact opposite. Here we started with two numbers, and both taking the 4th root of them. So what we can do is we can combine these by multiplication. Okay? So what I did here is I just wrote 8 as 4 times 2, which is 2 times 2 times 2. Or 8 is equal to 2 cubed. And 4 is equal to 2 times 2, or 2 squared. So I rewrite the problem as the 4th root of 2 cubed times the 4th root of 2 squared. Now, since I'm taking the 4th root of both of these numbers separately, I can just take the 4th root and 1/4 root and multiply them together inside the 4th root. Just going the opposite direction of the last problem. Now, 2 cubed times 2 squared, the bases are the same, so I add the exponents, and it's 2 to the 5th. But I want this 4 to match up with a 4 in here, but there's no 4. So I'm going to write it as 2 to the 4th times 2 to the 1. Again, they're both 2. Bases are both 2. Exponents are 4 and 1. So again, that would give us 2 to the 5th. So these guys are equal. And I can break these apart by multiplication. And this becomes the 4th root of 2 to the 4th times the 4th root of 2, which is the same as 2 to the 1. Now, the 4th root of 2 to the 4th is just going to be 2. And that gives me this final answer. Now, I just want to make a side note. If I had the 4th root of -5 to the 4, right? And again, notice the -5 is in parentheses. This here, the 4's cancel out, but I'm going to get a 5 because whenever we have this as an even number, if it's an odd number, then it always cancels. When this is an even number, if you have a negative in the parentheses raised to the 4th, you're always going to get a positive number out. And we'll talk about that more in later weeks. It's just a decision that had to be made because, well, otherwise it wouldn't be a function. And we'll talk a little about that later. But if you have a -5, now if I had the 4th root of -5 to the 4, then this one is undefined. Because in this case, you have -5 to the 4th power. This is 5 to the 4th times a -1, essentially. And you can't have an even root of a negative number. So this is a positive number, you're taking the 4th root of it. This is a negative number. So just note that distinction. This is not the... Okay? So let's work on the last problem. Is similar to the first two, except for the fact we're going to not use the multiplication property, we're going to use the division property. Okay? So what we're going to do here is we're going to take the 4th root of 81 over 16. Okay? Now before I do anything, I just want to note what 3 is. So I know that 81 is equal to 9 times 9. But 9 is 3 times 3, and this 9 is 3 times 3. So 81 is equal to 3 times 3 times 3 times 3, which is equal to 3 to the 4th. And we know that 16 is equal to 4 times 4, but 4 is 2 times 2, and 4 is 2 times 2. So 16 is going to be equal to 2 times 2 times 2 times 2, which is equal to 2 raised to the 4th power. Now, what I'm going to use here is I'm going to use the division property of roots. So we have 81 divided by 16. Well, the division property says that if I'm taking the 4th root of the quotient of two numbers, I can take the 4th root or whatever root of each number individually and then take the quotient. Well, I know that 81 is 3 to the 4th, so this is just really the 4th root of 3 to the 4. And this is really just the 4th root of 2 to the 4 because 16 is equal to 2 to the 4. You notice the trick in solving all of these is breaking them down via multiplication as far as possible and writing them in terms of their exponents. That's been the trick for all of these. Well, the 4th root of 3 to the 4 is just 3, and the 4th root of 2 to the 4 is just 2, so our answer is 3 halves or 1.5. Okay? Sounds good, I hope. Now, there's one more problem that I was going to do over here. And that problem, let me just find where that went. Okay, where was that? Just be 1 second here. I wrote down these problems so I can work them out for you guys. Now I'm missing it. How'd that happen? Give me 1 second. Oh, here we go. Got it. So we're going to apologize about that, so hopefully you're still watching the video. But this one, what we're going to do is we're going to do subtraction. We did multiplication, division, now we're going to do subtraction. And so what we're going to do is we're going to take 5 times the cube root of 16 minus 11 times the cube root of 2. Now, the only chance we have at adding these, if you can't see too well, it's 5 times the cube root of 16 and 11 times the cube root of 2. Now, we start out solving this problem the same way as we had before. We're going to take the numbers inside the roots and we're going to write them, we're going to break them down in multiplication as much as possible. The 2 I can't break down. The 2 is just 2 times 1 is 2 to the 1, right? So, but the 16 we can break down. So the 16 is the same as 4 times 4, which is the same as 2 times 2, which is 2 times 2. So we have 1, 2, 3, 4. So 16 is equal to 2 to the 4th power. So I can rewrite the problem as 5 times the cube root of 2 to the 4 minus 11 times the cube root of 2. Okay? Now, I want to simplify this guy here. This side is just 11 times the cube root of 2. I can't do anything really. But here, if I had a 3 here, I could cancel it with this 3. So I'm going to notice that 3 plus 1 is 4, so I'm going to pull out a 2, like I did in the last problem or the one before. And I'm going to write this as the cube root of 2 times 2 cubed minus 11 times the cube root of 2. And notice that this 2 cubed is under the radical sign. Just my writing was not so great. So now what I'm going to do is I'm going to use the fact that if I'm taking the cube root of the product of two numbers, I can take the cube roots of the numbers separately and then take the product. So this is going to be equal to 5 times the cube root of 2 times the cube root of 2 cubed minus 11 times the cube root of 2. Okay, now why is this good? It's good because this 3 and this 3 cancel. So I'm going to have 5. So all I've done is like all the other problems, I've just started out and I've been simplifying the numbers under the radicals as much as possible. So I can write this as 5 times the cube root of 2 times 2 minus 11 times the cube root of 2. Now, I can multiply these in any number. So this is 5 times the cube root of 2 times 2. So this is 5 times 2 is 10. So this is 10 times the cube root of 2 minus 11 times the cube root of 2. Alright, now you can think of this kind of like 10x minus 11x is going to be negative 1x or negative x, and the answer in this case can be the negative cube root of 2. The other way, if you're not comfortable with that, is you can use the distributive property and just pull out the cube root of 2. So this would just be the cube root of 2, and I'll do it the other way in case you're not comfortable with this way, times 10 minus 11, which is equal to the negative cube root of 2. Very good. Now, the other way you can think about it is you can think of this cube root of 2 like an x or a dollar sign or whatever. You have 10 cube roots of 2 here. You have 11 cube roots of 2 here. 11 minus 10 is 1, but 11 has the bigger magnitude here, so it gives you you don't have 1 cube root of 2 left. You have a negative 1 cube roots of 2 left. Okay, so hopefully that wasn't too confusing. But another way to think about it again is they both have a cube root of 2 in common, so you can pull out the cube root of 2, and 10 minus 11 is negative 1, so it's negative 1 times the cube root of 2. And you notice this is just a distributive property because cube root of 2 times 10 gives me 10 cube root of 2, and cube root of 2 times negative 11 gives me negative 11 cube root of 2. So in any case, I hope this answers the questions, and good luck, and if you have any more questions, feel free to ask me. Thanks, and have a wonderful day. Bye.